Chemistry by Sir Sadiq Amin.
Do you see the book?
Yes, sir.
Okay, so we discussed about ionic covalent bonding now, and we will talk a little bit more about the covalent bonding. Okay. We talked about the evidences and everything. Okay. Okay. Ionic radii and polarization of the ions. We'll talk about this today. Along with this, we'll work on the percentage ionic character. Okay. And then some of the properties of the ionic substances. Then we'll definitely move to the covalent bond once again. But these topics are still left, so we are going to work on that. So the first thing is ionic radii and polarization of the ions. That's our topic for today. Okay. So first of all, we all know about the ionic radii and all this stuff. We know about it. We already discussed that what is happening to the ionic radius and what is happening to the ionic radius across the period and what is happening to it down the group. So this is down the group. This is down the group and this is across the period. Is my voice clear to everyone? Can you hear me?
Yes, sir. No.
Okay. Your mic should be off. So, what are our objectives behind it? And what is the polarization? First of all, polarization of the ions, what does it mean here? Polarization of the ions means that how is the charge distributed on the ions? Okay. Is it exactly in the center of the ion, or the charge is somewhere like in this condition? For example, if this is the ion, is the charge exactly in the center? So this is the nucleus and this is the electronic cloud, okay? Is the charge exactly here, or it is a kind of disturbed like this? Is the charge disturbed like this? I mean to say this area, okay? This is called the polarization actually. So when we are moving, we will see, first of all, what are the objectives now? Understand the effect of ionic radius and ionic charge on the strength of ionic bonding. Okay, so we need to understand first of all the effect of the ionic radius and ionic charge on the strength of the ionic bond. And then we'll talk about understand reasons for the trends in ionic radii down the group in the periodic table for a set of ions like nitride ion and aluminium ion. Then we are going to work on the third part, understand the meaning of the term polarization applied to ions. Okay, so three things we are going to work on it right now. When we are working on these three things, first of all, let's move to that part once again. So, can we measure the ionic radius? This is the question. So, it's very difficult to measure the ionic radius. And the reason for that is that it depends on the environment, in which environment the ion is. Like for example, if I want to talk about sodium, positive, and I want to measure this sodium, I want to find it alone. Okay, but we cannot find alone sodium. So that's why sodium will be surrounded by sodiums, sodiums, so many sodiums will be there. That's the environment. So that will not be actually visible for us for any device to measure in this particular way. So that's why it's very difficult. That's the nature of the ion, in which environment it is there. Like sodium chloride, you're taking the example. So sodium is followed by chloride, chloride by sodium, then again sodium by chloride in this particular way. Okay? Are you with me?
Yes, sir.
Okay, now let us see how the ionic radius is basically seen here when we talk about the ionic radius. Some of the tabulated information is right there in front of you, which I'm displaying right now. Group 1 elements are there. We'll see the trend in the ionic radius. What is happening to the ionic radius? So you can see there's lithium. I'm moving down the group. Alkali metals. Okay, down the group. Look at the configuration. 2, then we have 2 and 8, we have 2, 8, 8, and we have 2, 8, 18, and 8. Yani all of them are having a complete outermost shell. Look at the ionic radius that is measured in nanometer. What is happening? From 0.76, you're moving to 0.152, which is an increase. Right? That's about the anion. Sorry, that's about the cations. Cation is a positively charged ion. The ion which is moving towards cathode is called cation. It must have a positive charge on it. Now, if we look into group number 7, halides ion now, they're negative, they're called anions. Anions are those ions which are moving towards an anode. Right? Anode is positively charged, but they must be negatively charged. Now you can see from fluoride to chloride to bromide to iodide. Look at the atomic electronic configuration. It is 2, 8, 8, 8, 8. After gaining 1 electron, they're all completed with their outermost shell. Focus on these values. What is happening down the group? From 0.133, we are moving to 0.22, right? So there is an increase in that. Are you getting my point?
Yes, sir.
Why there is an increase in the radius? First of all, I'm not talking about the positive radius, the negative radius. The increase is, I told you when you're talking about the radius, you have to mention this according to actually 3 points. What is happening to, I'll write those 3 points right now here so that we can understand these 3 points. The 3 points are, let me write it here. So those 3 points are ionization energy, ionization energy. Number 2, shielding effect. And number 3, the effective nuclear charge. Do you see my screen?
Yes, sir. Yes, sir.
Okay, so we are having the effective nuclear charge. These 3 points are to be considered when we are working on the ionization, when we're working on the radius. The 4th one is radius. So whichever one of you them you are explaining, you have to talk in the language of the rest of them. Okay, so let's suppose I'm explaining right now the atomic radius. I have to explain the atomic radius in terms of ionization energy, in terms of shielding effect, in terms of effective nuclear charge. So right now I'm going to explain it on the basis down the group. Okay. There are two explanations. One is down the group and the other is across the period. So right now we are talking about down the group. So what is happening to the ionization energy down the group? The ionization energy decreases down the group. So there is a decrease down the group for ionization energy. Then what is happening to the shielding effect? The shielding effect is increasing down the group. And the reason for that is because more and more shells are there. So the electrons which are at the outer shell, they are repelled by so many other electrons. That's called shielding. The inner electrons, they don't want the outer electrons to be attracted by the nucleus. So they are shielding. The inner electrons are covering the nucleus from them. That's shielding. Why ionization energy is decreasing? The reason for that is that more and more shells are added. So the force of attraction between the nucleus and the outer electron is getting lower. So you can easily release the electron from there by providing less amount of energy. The more the number of shells, the less is the ionization energy. The more the number of shells, the more is the shielding effect. Effective nuclear charge is the third point. What is happening to the effective nuclear charge? So effective nuclear charge decreases down the group, whichever group you're talking about. And why effective nuclear charge is decreasing? Because the nucleus is crowded by so many electrons where its effect is not reaching properly to the outer electron. What is that effect? The force of attraction. It's not reaching. So that's why when you put more shells, you are covering the nucleus. Consider the nucleus to be a magnet. The more you cover it, the more the magnetism is affected. Magnetism here, I mean to say the effective nuclear charge. Are we clear? Shall I move on?
Yes, sir.
Okay. Now, when we talk about these points, you will see that these two things are happening sidewise and parallel. Okay?
Actually, sir, can you repeat one time? One more last time. Just like small repetition.
You can watch this video later on. Okay, this will be uploaded, so don't worry about it. Whatever, that's why I'm recording it so that it's easy for you. Okay. Moving on to the second table now, and this table is telling me period number 2 and period number 3. Period, I mean to say moving from left to right. Okay? When we are moving from left to right in the periodic table, we see the number of protons first of all. Protons are showing me the atomic number from 7 to 8 to 9, and from -3 ion to -2 ion to -1 ion. Look at the configuration. They all have the same electronic configuration. But radius, which is the ionic radius, is affected tremendously. And you can see it is decreasing. What's the reason for this decrease? The reason is that when you add more electron to the same shell, the shell is the same. Across the period, you're not increasing the shell if you're moving in period number 2 means shell number 2 you're moving. So you have 5 electrons in the outermost shell for nitrogen. Okay? Nitrogen needs 3 electrons. So those 3 electrons when you bring, let me zoom in once again and let me explain this to you so that things are very clear to you. Okay. I will draw a nucleus here for you. This is the shell starting from nitrogen. How many electrons are there? 1, 2, 3, 4. This is how to draw the electrons in pairs. Now 7 electrons I have drawn. Okay. So I need to remove these electrons and draw it once again for you. Let me change the color also. 1, 2, 3, 4 and 5. These are the electrons in nitrogen. I'm moving from nitrogen to fluorine. Now, In case of nitrogen, how many electrons are you adding to it? You are adding 1. This 1 will be -1, so this will be for fluorine now. The force of attraction between the nucleus and this electron, 5 are already there. Now you added 1 electron to it. You added another electron to it. Force of attraction, you added another electron to it. The force of attraction is there, but what are you adding? You are adding negative. So negative with negative and negative. Now you have added 3 negative charges. Bringing 1 negative is bearable, but bringing 3 negatives, they are unbearable. So the shell is going to expand, otherwise there will be no stability. Are you getting my point?
Yes, sir.
So the more negative charges you are bringing, the more repulsion you are bringing, because 5 electrons are already there in nitrogen. So you brought 3 more to it. Now those 3 more will settle down. It's just like a sofa in which 5 people are sitting there, but you are bringing 3 more to that sofa. So the sofa should be a flexible one. Yani when the 6th person will sit in it, it should increase a little bit. Then the 7th one, it should increase a little bit. Then the 8th one, it should increase a little bit more. So consider it's a circular sofa, and there were 5 people sitting in it. They were quite relaxed. But when you want to bring 3 more people, you have to increase the size of the circle so that the space is created for it. And that space is created because electrons are negatively charged. They start repelling each other, and they increases the size of the shell. That's why the negative radius is increasing. Right? Are you clear?
Yes, sir.
Moving on to the positive radius now, the cationic radius. The positive radius is basically, if you look into that one, you will see from sodium, it's also across the period, okay, to magnesium to aluminium. The number of protons are 11, 12 and 13. Configuration is 288. But you can see the radius, it is 0.102, but right now it has been decreased. So there is a decrease. Right? So what is the conclusion? If you are moving in plus ions and you see that there is an increase in the charge on the ion, the radius will decrease. Okay? Are we clear? That's the conclusion part. And what about the negative ions? The negative ions is the reverse of that. So if I write those charges once again, if I start with -1 and I start moving to -3, what is happening to the size, the atomic radius? It is increasing. So the size of the negative ions, when you are increasing the negative charge, the size will increase, the radius. And the size of the positive ion, when you are increasing the charge, it will decrease. So what is the reason for the positive one now? The positive reason is that you are eliminating the electrons. When you start eliminating the electrons, actually what is left with you? For example, in case of sodium, if I display it here, in case of sodium, there are 8 electrons in the outermost. It's 2, 8 and 1. That's the configuration. And how many protons are there? 11 electrons are there in sodium and 11 protons are there. Right? So they're balancing the force of attraction of these 11 protons on 11 electrons. But if you remove 1 electron, and they're left 10 in number, so proton are attracting it more, the 10 and 11 force. So they will definitely, there will be shrinkage. Right? So if the same 12 protons are now there and now 10 electrons are there, so the force of attraction, that's for magnesium now with 2+ charge. So the force of attraction is much more. And so on, this will increase. When force of attraction is more, then the size will shrink. It will shrink, okay? Do you have any point? You want to, you want me to elaborate it a little bit more, or it's fine? It's fine?
Yes, it's fine.
Okay. We will take 5 minutes of break here, and then we will work on the next topic, that is the polarization. So as I'm making the videos, that's why we need to get the